हेलो फ्रेंड, वेलकम बैक टू आवर न्यू वीडियो। तो आज के इस टॉपिक में हम डिस्कस करेंगे रिलेटिविटी एंड क्वांटम मैकेनिक्स, द फाउंडेशन ऑफ मॉडर्न फिजिक्स। So the earliest recorded systematic effort to assemble knowledge about motion as a key to understanding nature phenomena were those of the ancient Greeks. Set forth is sponsored from the Aristotle. There was a natural philosophy of explained deduced from assumption rather than experimentation. For example, it was a fundamental assumption that every substance had a natural place in the universe. Motion then resulted when as moving from some instant in the past. The creation of the universe towards some end goal in the future its natural place. The remarkable agreement between the detections of Aristotelian physics and motion observed throughout the physical universe, together with a nearly total absence of accurate instruments to make contradictory measurements, led to acceptance of the Greek view for nearly 200 years. Toward the end of that time, a few seconds of scholars had begun to deliberately test some of the prediction of the theory, but it was Italian scientist Galileo Galilei who, with his brilliant experiment on motion, established for all the time that absolute necessity of experimentation in physics and consequently initiate the disagreements of Aristotelian physics. Within 100 years, Newton had generalized the result of philosophy of Aristotle was gone. With the burgeoning of experimentation, the following 200 years saw multitude of major discoveries and contemporary development of physical theories to explain them. Most of the later dinosaurs failed to survive increasingly sophisticated experimental tests, but by the dawn of the 20th century, Newton's theoretical explanation of the motion mechanical systems had been joined by equally impressive laws of electromagnetism and thermodynamics as expressed by Maxwell, Carnot, and others. The remarkable success of Plate these laws led many scientists to believe that description of the physics universe was complete. Indeed, McLaughlin, speaking to scientists near the end of the 19th century, said the grand underlying principle has been firmly established. The future truths of the physics are being locked for in the sixth place of decimals. Such optimisms or prisms, depending on your point of view, turned out to the premature as there was already rising cracks in the foundation of what we now refer to as classical physics. Two of these were described by Lord Kelvin in his famous Baltimore lectures in 1900 as the two clouds of horizon of 20th century physics. The failure of theory to account for the radiation spectrums emitted by the black body and the inexorable result to the Michelson Morley experiment. Indeed, the breakdown of the classical physics occurred in many different areas. The Michelson Morley null result contradicted Newton's relativity. The black body radiation spectrums contradicted predictions of the thermodynamics. The photoelectric effect and the spectra of atoms could not be explained by the electromagnetic theory. The exciting discoveries of X-rays and radioactivity seemed to be outside the framework of classical physics entirely. The development of the theories of quantum mechanics and relativity in the early 20th century not only displaced Kelvin's dark clouds, they provide answers to all the puzzles listed here and many more. The foundational parties add to the macroscopic systems of solids, liquids, gases, and plasma have given us deep understanding of the intricate workings of nature, have revolutionized our way of life. In part 1, we discussed the foundation of the physics of the modern era, relativity theory,